Okay, today I'm going to show you some helpful hints on using the CRA model in everyday math skills. Whether you're doing Tier 1 instruction or intervention or remediation, you should have the CRA embedded in your math lessons. So the first thing I want to do is just to show you how the CRA model works with two skills that are traditionally taught using procedural steps or traditional algorithms. So I'm going to start off with fractions. So when we look at a problem like 1/3 plus 2/6, we've been taught to, or we've even taught other people to find the least common denominator. And I'm going to show you using concrete squares on how to add fractions with unlike denominators without finding the least common denominator. So the first thing I'm going to do is model 1/3. And we know that our ultimate goal is to get like denominators, right? So now I'm going to model 2/6. And in order to add fractions with unlike denominators, our goal is to get like denominators or have the same equal parts. And in looking at this, it doesn't have equal parts. So how do we get equal parts? Hopefully someone sitting down is saying, add another 1/3. See how smart you guys are? So here's another 1/3. Now we have equal parts. Okay, over here, 1/3 equivalent fraction is now 2/6. So we have 2/6 plus 2/6 equals 4/6. So we did all of that without finding the least common denominator. Now let's look at this even further to the representational. So I just showed you the concrete. Now let's look at the representational using those same fractions. 1/3 plus 2/6. Can you see that, cameraman? Okay, so let's go ahead and model 1/3. And now we're going to do 2/6. Okay. Now we are tasked with finding or getting the same amount of parts. And hopefully you know by now to add another 1/3. So the equivalent fraction for 1/3 is 2/6. And the 2/6 here just stay the same. And we have 4/6. Now, you also know that 4/6 can be simplified. And we've been taught to simplify fractions, you have to find the greatest common denominator. So I'm going to show you how to simplify that fraction without doing that. So I'm simply going to model 4/6. 1, 2, 3, 4. Okay, we have to think of that fraction bar as also a division bar. So we're going to divide this into groups. But you have to have the same amount of squares and they have to look just alike when you're dividing the groups, or else you won't get the right answer. So here's a group here that is not shaded. So I can circle that. And here's another group here, and here's another group. So how many groups do you have total? You have 3 groups total. And how many groups are shaded? 2. So you've just simplified that fraction without finding the greatest common denominator. Now, the abstract part in this, of course, would be where you want to be with your kids. You will want to be there. But before you get here, you should go through the whole phases of the CRA model. And I'm going to show you one more on division, just to show you that this could be done for any skills, especially primary grades. I'm going to show you division. And we're going to work on this problem, 51 divided by 4. So I'm going to show you what 51 look like. We're just going to pretend that these are base 10 blocks because I don't have any at my fingertips right now. So we have 51. Okay. Now, hopefully you have talked to your, by now kids should know what division means if you're doing this particular problem. So we're going to divide 51 4 ways. So we're going to put them into 4 groups. So let's go ahead and do that. So here's 4 groups, but here I have 11 stuck over here. So I don't have enough 10s to give each group. So what I'm going to do is trade this 10 in for 10 ones. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and then one more makes 10. And now I can definitely divide these, okay, in these groups. So here 1, 2, 3, 4, 1, 2, 3, 4. Now, I don't have enough to give each group one, so I'm left with 3. So in each group, I have 10, 11, 12 with a remainder of 3. So here's the concrete. Now let's look at this in the representational model. Okay, so I'm going to show you 51. 1, 2, 3, 4, 5. Okay, here I have 4 groups. I have enough to put 1 10 in each group. And here's that 1 left over again. So I'm going to trade that in, and I'm going to have 10 ones. 5, 6, 7, 8, 9, 10. And each group will get a 1 until I run out. Okay, so how many? Oh, I added one more. Sorry about that one. Didn't mean to. But I'm left over with 3. I don't have enough of these to give each one. So 10, 11, 12. There's 12 with a remainder of 3. I kind of added too many. All right. Now let's move on to place value rounding. So I'm going to use a hundreds chart that I've already filled out. And if I were you, I will have this chart go for homework. Every day my students will complete this chart because it is very useful. You can use it on your DBAs and your actual SOL tests. All students should be making a hundreds chart because you can use it for rounding, addition, and subtraction. So I'm going to complete the rest of this. Okay, and I already drew down my dark line to put them in halves. I have a set of 10s over here and also a set of 10s over here. Now, let's say I wanted to round the number 23 to the nearest 10. The one thing I want to have the children to do is show or represent the number 23. So they're going to shade this in. And they're going to stop when they get to the 23. Okay? And then they're going to visually see that 23 is closer to 20 than it is to 30. Okay? Now, that's your concrete and your representational. Now, for your abstract, I will use the same graph paper and make a place value chart. Okay, and we're going to go ahead and write 23. Okay, I'm going to underline the place I'm rounding to and circle the 3. Okay, so obviously this 3 isn't greater than 5, so I cannot do anything, but that 0 or that circle around the 3 means that 0 stayed the same. We just dropped it down. And then that 2, we dropped on down. So 23 is rounded to 20. I love rounding. All right. Now, the next thing we're going to do is part to whole with addition and subtraction. And I think we're only going to do subtraction. Okay, I'm going to do a word problem, but I'm going to show you what it looked like at the end, but I'm just going to work through this. So, Miss Brown baked 62 cakes for the church bake sale. She sold 39 cakes. How many cakes were left? The very first thing we want to do is represent or show 62. So here's my 62. So the whole is 62. Okay. And the part is 39. And we don't know what the other part is. But we're just going to assume that everybody is bright and everybody knows that we have to subtract. So we have to subtract 39. Now, when I look at this, I know I can't subtract 39 because there's only 2 ones in the ones place, and I would need 9. So hopefully somebody can point out that the next logical step would be to break one of my 10s down to 10 ones. Okay, so let's count them out. 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm going to have to cut one. 9, 10. Okay. Now I have enough to take 9 from. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9. And now over here, I can take 3. 3 10s. 1, 2, 3. And I'm left with 23. The one thing students always get confused when they are regrouping from the 10s place, they actually think they're taking 1 and they're not. They're taking a whole 10 and adding to the ones place. Okay, so now let me show you what that looks like in the representational phase. Here's that same word problem I just went over. Miss Brown baked 62 cakes for the church bake sale. She sold 39 cakes. How many cakes were left? Sorry. So I put this in a graphic organizer, which everyone should be doing at some point. Here in my understand, I wrote the question for my plan piece. I knew that 62 was the whole, 39 was the part, and we needed to find out how many cakes were left. And here it is here in the representational part. Even though I used these for the concrete, I drew this out in my solve piece. And your students should be doing the same thing. On every single question, on every single problem, your students should be representing it in a representational phase until they can do the abstract, until they have mastered those phases. Other than that, they should only draw, and you should be able to see what they're doing from their drawings. And when your students are testing, please, please, please walk around your classroom. Look at what they're doing. Make them show their scratch work, and you're picking the scratch work up for extra credit. Please, please, please examine their work. I think that is all I have. And after this recording, I have another video of kindergartners doing part to whole. I was so impressed with it. Thank you guys. And if you have any questions, please don't hesitate to ask. Thank you.